Welcome everyone. In this lecture, we are going to see the difference amplifier or differential amplifier, that is nothing but a subtractor circuit. Okay, as already we have seen the differential amplifiers with the number of operational amplifiers we added. That is, we have designed the differential amplifier with one op amp, then we have designed differential amplifier with two, and with three operational amplifiers. Now we are going to design a differential amplifier and that can be acts as a subtractor. Okay. In the circuit diagram we can see that there are two input signals. We have provided to the inputs. Inverting input terminal will have input signal VA and VB is the input to non-inverting input terminal. In this circuit we can see that the values of resistors are selected such that they all are having the same value R. To find out the output voltage of such a circuit, we can use the superposition theorem, as already we known about the superposition theorem, and we have also find the output voltage of such of the circuits. Okay, so now we want to write out the output voltage, and that must be is equal to VB minus VA. Okay, let's start to derive this equation. Here is see that for all resistors, as already we have seen that having the same value, and that is equal to R. So if all resistors are having the same value, its gain will become is equal to 1. So the first of all we can find out the output voltage, and that can be written as output voltage V0. Consider one input signal VA simultaneously, then we consider the another input signal VB. When we consider VA is the input signal and VB is equal to 0, op amp is in inverting configuration, right? It means that non-inverting input terminal is at ground potential. So if it is in inverting, output voltage equation is similar to the inverting op amp. So what should be the output equation is minus RF divided by R1 into VA. So the output voltage equation is minus RF, which is again R, R1 is again R, minus R by R into VA. Okay, this is the output voltage equation when VA is present. Okay, now consider VB is present, and by superposition theorem add this voltage also. When VB is present and VA is equal to 0, this VA is equal to 0, this terminal is at ground potential. Input is given to non-inverting input terminal, and that input voltage is V1 voltage. Okay, so now this is operational amplifier is in non-inverting configuration, which will have V1 as input voltage, not directly VB, V1 as input voltage. So output voltage equation of non-inverting amplifier is 1 plus RF by R1. What is RF is R, R1 is again R. 1 plus R by R into input voltage V1. Okay, so what should be output voltage equation? V0 is this RR will give us 1 minus VA plus, again this RR is equal to 1. So it is 1 plus 1, 2 into V1. Here we need to find out the value of V1 voltage. Okay, so first of all go for what is the V1 voltage. V1 voltage is nothing but voltage generated across this resistor R. So by voltage divider rule, we can write here to find out the V1 voltage, we have to apply voltage divider rule. Okay, and what is voltage divider rule is? Voltage divider rule is nothing but we want to find out voltage across this resistor. So this resistance divided by total resistance of the circuit into input voltage. So across which resistor V1 voltage is present? R. R divided by R plus R into VB. So V1 is R divided by R plus R into VB. So again it is R divided by 2R. So it is 1 by 2. What is V1 is VB by 2. Put this one into above equation. So output voltage V0 is equal to minus VA plus 2 into V1 is VB by 2. This 2 will get eliminated. What is output voltage? Minus VA plus VB. So output voltage is VB minus VA, or we can say that Output is difference between input at non-inverting minus input at inverting input terminal. Hence, the circuit is called as a subtractor circuit. This is the output of a subtractor circuit. Okay. In the same way, we can design the difference amplifier or summing amplifier where the output is, or if we are taking negative sign outside here, how this can be written as, if we are taking negative sign outside, output voltage V0 is minus of VA, how we can write it, minus VB, right? Yes. So this is the output voltage. Now we can also design the differential amplifier that can be acted as a summing amplifier. Means with the help of same circuit, we want the output must be the summation of number of input signals. Okay. So let's see that summing amplifier using differential configuration. Already we have seen the summing amplifier with inverting configuration, summing amplifier with non-inverting configuration. Let's see that the summing amplifier that can be designed with the help of differential amplifier. Okay. So where more than two inputs we are applying at both of the input terminals. So that can be acted as a summing amplifier of circuit. Okay. So first of all we have to draw the circuit for summing amplifier. Provide inputs 1, 2. So this resistor is again having the same values as R. Here again we are providing more than one inputs to the inverting terminal also, and more than one input to the non-inverting terminal also, and finding out the voltage across the load resistor RL. Okay. So this resistor is R, this one is again R, and provide the another input signal as, make this one as positive input signal. For simplicity we are providing positive input signals VA and VB. Okay. So plus VA plus VB, this is plus VC and plus VD. Okay. And operational amplifier we are providing inputs, feedback resistor is again having the same value as R. So voltage at this point is V1 and voltage to the inverting input terminal is V2. What should be output is, we have to design or we have to derive the output voltage equation as, it is minus VA minus VB plus VC plus VD. Okay. So this is nothing but the summing amplifier using differential amplifier. It is summing amplifier using differential amplifier. Okay. So we want to find out the output voltage, and that can be obtained by using the superposition theorem. Okay. So here we want to write out the superposition theorem, and that is nothing but we have to find out the output voltage due to VA alone, then output voltage due to VB alone, then output voltage due to VC and VD alone. When alone input signal sources will be acting, the other three input signal sources must be is equal to 0. Okay, it means that only VA is active source and all other sources reduces to 0. Okay, so consider first we want to find out the output voltage due to VA alone. The condition is when VA alone is there, then what about the other sources? Then reduce all other input voltages. What are this? VB, VC and VD to 0. Okay. So we can also redraw the circuit for such kind of case. That is, only VA is present and all other sources are 0. Minus plus. So what should be, about the another source? This is VA is present. VB is also reduces to 0. So this resistor is R, and again we can redraw the circuit. This is R. All R reduces to 0. See that VB is reduces to 0, VC is reduces to 0 and VD is also reduces to 0. Then circuit will be simply look like this. And we have to find out the output voltage because of VA alone with reducing all other voltage sources VD to 0. Therefore, what should be the output voltage? V out, or we can write that output voltage because of A is equal to, see, if only A is present, which is given to inverting input terminal, so we can write that, or we can say that as input is to the inverting, we can write the output voltage equation of inverting amplifier with feedback. So the output voltage equation of inverting is minus RF by R1 into input voltage. It is minus RF by R1 into input voltage VA, or it is simply is equal to minus of VA, as this R will cancel out each. Make this one as equation number 1. Okay. So this is one of the example that we did with all other sources reduces to 0 and only VA is present. Similarly, we can write here for VB is present, VB is alone present, and VA, VC and VD reduces to 0 volt. Same, it will be looking like same. Circuit will be looks similar to this, only here it is VB. Okay. So again circuit will be in inverting configuration and output voltage V0B. We can write it or we can highlight with some other color. V0B is equal to minus R divided by R into VB. So it will be again minus of VB. This is second equation. Okay. Now the first two cases we have seen that output voltage because of VA is minus VA and output voltage because of VB is equal to minus of VB. Now check out the output voltage for other two sources, input sources, that is VC and VD. Okay. So if now the input voltage, output voltage due to VC alone and other sources VA, VB and VD set to 0. Okay, that is input voltages VA, VB and VD set to 0, only VC is present. How this circuit will be looks? We will redraw it again here. All other sources VA, VB, we are connected to ground. Make this is VA, this is VB and that we have connected to ground. This is the feedback resistor. Inverting input terminal, non-inverting. Which signal is present? Only VC is present. VD is also is equal to 0. R, only VC is present, plus VC. This is R. Okay, this is RL. We want to find out output voltage. So the circuit will be now will reduces to such type of circuit, that is VA is reduces to 0, VB is reduces to 0, VC is present, VD reduces to 0, and this is the resistor R that present here. Okay, we want to find out the output voltage. So because of which here these two resistors we have drawn separately, but both are resistor in parallel combination. So for these two we can again write the equivalent resistance, and what should be that value is R in parallel with R. Equivalent resistance is R into R divided by R plus R square by 2R, or we can simply make this one as R by 2 and erase this. Okay, so only one resistor is present, which is R by 2 resistor, and voltage across this is V1, that will act as input to the non-inverting input terminal. Okay, now we know that when there is input given to the non-inverting input terminal and inverting input is at ground potential, circuit is in non-inverting configuration, and output voltage for such circuit is 1 plus RF divided by R1 into V1. Okay, so if this is the case for equation number 3, now we know that what is RF is equal to R, and what is R1 is again R in parallel with R. So again this is both are in parallel combination, so it will reduce us to R by 2. Okay, so that if it is R by 2, you can make cancel out this and write this one as R by 2. So what should be the V1 voltage? First of all, simply write the equation for V0 is equal to 1 plus RF is R and R1 is R by 2 into V1. Okay, now when we are solving for this, what should be the equation? Or first of all, we want to find out the V1 voltage. V1 is voltage across R by 2 resistor, and by voltage divider rule, this V1 voltage is voltage across R by 2, so it will come to the numerator divided by R plus this R by 2 into input voltage VC. Okay, solve for this. It is R by 2 divided by 3R by 2 into VC. What should be the value? 2R plus R divided by 2. 3R by 2, and this is R by 2. So VC divided by 3. VC divided by 3. R by 2 will get eliminated. So V1 voltage is simply VC divided by 3. Okay, now we want to write the equation for output voltage V0. Okay, first we'll see that here is for first output voltage V0 is equal to 1 plus R divided by R by 2 into VC divided by 3. Okay, solve for this. R divided by 2 plus R divided by R by 2 into VC by 3. Okay, so again this will reduces to, you can solve it, that is 3R by 2, that is R plus 2R by 2 and divided by R by 2 into VC by 3. So output voltage is equal to VC. This 3 and this 3 will get also eliminated. So this is the output voltage. When output voltage due to VC alone, okay, that is equal to VC. Similarly, when VD is alone, the output voltage is again similar to, what should be this equation number 3, and this is equation number 4, that is, or circuit will be similar to the previous ones. How we can say that? Because VD is given to again non-inverting terminal, so that irrespective of VC here, now it is VD, and all other register combinations will remain same. That is, this will become R by 2, again this will become R by 2. So the output voltage or the circuit will be similar, simply the input signal source will become from VC to it will become VD. So that again the same output equations we are writing, that output voltage is equal to 1 plus R divided by R by 2 into V1, and V1 is R by 2 divided by R plus R by 2 into VD, irrespective of VC, now there will be VD, and that will reduces to VD by 3. So output voltage will become is equal to VD. So because of this, the same configuration will be there. We got equation number 5 as VD. Now we have to apply the superposition theorem to find out the output voltage. Okay, so apply superposition theorem to find the output voltage due to all 4 input voltages, and that is output voltage V0 is equal to output voltage, because of VA is V0A is equal to, this is V0C, this is V0D. V0A is minus VA plus minus VB plus VC plus VD. Okay, so what should be the output voltage? Output voltage V0 is equal to minus VA minus VB plus VC plus VD. What negative sign will indicate? Negative sign indicates that input is given to the inverting input terminal. So output voltage is the sum of the input voltages applied to the non-inverting input terminal, or plus the sum of the input voltages to the inverting input terminal. We can also rearrange this equation as minus VA plus VB plus VC plus VD, right? So this is nothing but output is sum of the input voltages at non-inverting, what are that? VC and VD, plus negative sum of input voltages at inverting input terminal. So that this circuit is also called as a summing amplifier. So the gain of this summing amplifier is 1, as we have set all the register values equal to R, and therefore the scale factor that we have selected here is equal to 1. So any scale factor can be used for the inputs by selecting the proper external registers. In this case we have selected the scale factor is equal to 1. So as output is the summation of the inputs given to both of the input terminal, circuit is called as the summing amplifier using differential amplifier. Okay, so in this way we have designed summing amplifier with differential amplifier. Thank you.